All right, hello everyone. Welcome. I hope you're all having good days. Had a nice weekend, stack weekend. Just want to start off with a couple of announcements slash reminders. We just finished our previous in-class assignment last Thursday. So that was definitely a tricky one. Actually, maybe even the trickiest one of the five in-class assignments that I'm going to have you do this semester. I am slowly working through grading those, and I hopefully made it clear I like to stay on top of grading, but it's also the time of the semester where everybody's super busy, and that is true for me as well. So I don't think I'm going to be as quick on the turnaround for this assignment as I have been on the first couple of assignments, but I do not like to have piles of grading just sitting around, so I'm definitely going to keep plugging away and trying to get those grades back to you sooner rather than later. Our next in-class assignment is actually 1 week from today. So in-class assignment number 4 is 1 week from today. That is the last one that we'll be doing before spring break. So after that in-class assignment, we're going to be kind of shifting into project mode a little bit, and there'll be one more in-class assignment after you get back from break. But most of the stuff that we talk about after break is going to be related to the project. So the whole back half of the class essentially is focused on working together in a group to do this project. I'll have a lot more information about the project once we get to that last week before spring break, which is this week right here. So we'll start talking about the project in a lot more detail. Just want to make sure you're aware that the next in class assignment's coming up, and actually it's going to be more over the topic that we're talking about on Thursday. So some of the stuff that we're talking about today may make an appearance on the in-class. Relevant. We're talking about snakes. I really highly encourage you to come to class on Thursday. Make sure you're aware we're going to be talking about unit testing, and that's what the next in-class assignment is basically about: is writing unit tests and doing things along those lines. So hopefully I'll see you here on Thursday as well. And actually, we're kind of making a shift in general. So we just finished up our unit on Git, and that also kind of ends our discussion about the command line and bash scripting and stuff as well. I'll still be using the command line. In fact, I'll be using it a little bit today. But more of the conversations that we're going to be focused on from here on out are not going to be related to Git, not going to be related to the command line, are more going to be related to code. So we're really focused on writing high quality code. The next couple of topics that we talk about, testing, and then also code quality, clean code, right? Both have to do with this idea of how do I write code that is good code, right? I want to know not just does it work, but also is it written well? Is it written in a way such that other people can understand? So it's going to kind of have a different feel here for the next few weeks, starting with today's topic. So we actually have two topics on the agenda for today. Debugging is the first one I'm going to talk about. I'm going to hop into conversation about files. And these are kind of loose ends, right? I'm trying to just provide you some extra tools for you to have in your tools. Tools in particular, that's something that a lot of students want to use on the projects that's coming up. So that's a big reason why I talk about files. Debugging is just a generally useful skill that I think all students should have more exposure to, and maybe we don't quite do as good of a job as maybe we should here in the CS department of exposing you to the debugger and all of the different things that it can do. So that's going to be the first part of today's topic. In fact, I have set up a repository with some examples that I want to work through with the debugger. So the first thing that we need to do actually is grab this repository. Now, before I do that, little side note, as we move more into the part, move away from the command line, we're not going to be using it nearly as much as we have been. I just want to point out that in the intro class, we recently switched to using VS Code for everything. Now, if you took the intro class before this past semester, which I'm assuming most, if not all of you did, you might be used to using Eclipse to write code in. Some students even prefer IntelliJ to write Java code in. I want to make it clear that for the purposes of this class, I actually don't really care if you use VS Code or if you use Eclipse or if you use IntelliJ or if you want to use Notepad, right? Like that's actually I think Notepad's probably a bad idea. But the other ones, definitely viable options. I'm not going to force you to use VS Code just because I'm using VS Code. That's the point I'm trying to make. Everything that I'm going to show you today and in the next few weeks can be done in VS Code and Eclipse and IntelliJ, right? They can all do the same things. It's just that if you're not using VS Code, if you're using Eclipse instead, you might have to look somewhere else. It might be in a different spot. The stuff that I'm showing you. So it's all there, including the debugging stuff that I'm going to talk to you about today. I know how to do this stuff in Eclipse and VS Code. I'm only going to show you VS Code though. So if you are, set on using Eclipse, again, not a problem. I don't care. That doesn't bother me at all. But if you have trouble finding some of the stuff that I'm talking about today in Eclipse, definitely have a chat with me after class or in office hours, and I can show you where all that stuff can be found in Eclipse. But I think the department as a whole is kind of shifting more towards VS Code, so and away from Eclipse. We've been using Eclipse for a long, long, long time, and I think 247 it might be the only class left that is still actually using it for much of anything. So I'm going to focus on VS Code because I believe that's kind of the new normal for the department. But I do realize there's kind of mixture in here. Some people who've had the VS Code exposure and some people who might have taken these classes before they switched over to VS Code. I think even 247 getting ready to switch over to VS Code in the next semester or two. Talk to them about it. I think that's on their to-do list. So I am going to use VS Code, but please feel free to use Eclipse or whatever IDE you are most comfortable with if you would like to for the purposes of the exercises today and also on the project as well. Not going to be picky about that. But I do need to get this repo set up. And, if you're used to using Eclipse or VS Code, you're probably already aware of the fact that, in VS Code, there's a button right here for cloning a Git repository. This is actually one of the first things we show to our intro students when they take the class. I can just paste the repository link right in here and it'll do everything for me. But since we've had such a focus on using Git, especially on the command line, I would like to actually do it that way today and show you how I can actually kind of use the command line and VS Code together if I want to. And actually, this is probably my more preferred way of doing things. I like to have control over my Git repositories. I like to do those commands via the command line while still doing my coding in VS Code or Eclipse. And so I want to kind of show you that workflow by, of course, starting out by going to the repository itself and then grabbing the URL. This part I feel like most people know how to do because it's pretty typical. And then once I switch over to the command line here, I'll do a clone and paste in that URL. Okay. So far, nothing too crazy here, nothing too complicated here, right? But this has only downloaded it onto our machine. If I want to actually get it open within VS Code, I then need to take the additional step of opening a folder. So I'm not going to go to clone git repository this time. I already did that. I did that on the command line. So I'm going to go to open folder instead. And now I need to go to wherever I cloned it. So you probably cloned it in a different spot than I did. Your computer is different than mine, right? So you'll need to figure out go to the place where you cloned the repository, which for me is in my 2307 folder. And here it is. This is the place where I cloned the repository on the command line just a moment ago. And so that's the folder that I wish to open within VS Code. And here we are. Once I've done that, everything is up and available. If you're having trouble with that part, you can use this. I'm not going to say that you can't click the clone button in VS Code. You absolutely can. I just really want to make it clear that there's more than one option available to you. I actually prefer doing it this way. I think that the command line provides me more control over using Git than VS Code does. So I generally prefer to use the command line to do all my Git repository management. But if you're more comfortable doing it through VS Code, by all means, as long as you can get done what you need to get done, I'm not going to argue. I'm not going to complain. But regardless, make sure you have this repository loaded up either in VS Code or Eclipse or whatever you're using for today. And this is definitely the kind of day where I hope that you have this open and are following along with me and trying out the stuff that I'm trying as I go through all of these various examples. Um, Starting with the very first one. So the one that's labeled example 1, that's where I want to begin. And we're going to begin with the basics. At least I hope this is true. Have already had some experience with the debugger and know how to do some of the basics. We cover the basics in the intro class in 1301, so I kind of assume that most people are at least a little familiar with using a debugger, but it's still good for you these concepts like this because we introduce them in the intro class doesn't mean that students use them a lot in the intro class. So I am going to cover the basics, and then once I get through those, we'll go into some more advanced debugging techniques that I'm pretty sure you haven't seen before. Maybe you have, but a lot of this stuff is not stuff that is covered a lot in our classes. So that's part of the reason why I wanted to have this conversation with you today. So let's talk about debugging. Actually, I want to contrast using the debugger with a more classical, maybe even more common way of debugging, which is just using print statements. I feel like all of us have probably been in this situation before where our code isn't working. So what do? We put in some print statements to try and figure out where the problem is, maybe print out the value of a variable along the way so that we can look at the value of that variable and see, is it looking right? Does it ever go off, in a different direction than what I expect? And there's nothing wrong with using print statements to debug. If I'm working on a small program, if I'm working on a small piece of code, or if I'm in a situation where I'm like 99% sure the problem is in this very small section, right? Then print statements, great tool. Certainly don't have a problem with using print statements to help debug code. There's actually a name for it. It's called fence posting. So if you look up fence posting as it relates to coding, that's using print statements to help you debug your code. The problem with using print statements to debug your code, I think, is best illustrated when you think of large programs that have lots of files, lots of methods, lots of variables. It can then very quickly get overwhelming to have so many print statements all over many different files, many different methods, many different variables, and trying to keep track of all of that. Not to mention the fact that when you're done debugging, you have to take all those statements out. So that's more work, that's more effort, right? Using print statements, a few print statements, not going to cause any harm. But if you have to put in a ton of print statements all over the place and you accidentally forget to take a few out, it's annoying. And that's going to, annoy your teammates, and it's not the most professional path forward. So in those situations, I think using the debugger is essential. It's a great tool to have in your toolbox. So let's start by chatting about the basics. In order to use the debugger, the first thing that we need is some sort of a breakpoint. So a breakpoint is just an indicator to the computer that we wish to pause execution at either a line number, or there's lots of different ways we can break. But the most common breakpoint, and the one that most students are introduced to first, is based on a line number. So if I come to this piece of code and I click, or I hover over line 6, you see that little red circle, and I click, I have now set a breakpoint. There is a breakpoint on line 6. Let me specify that. That tells the computer that we need to pause execution at that line, but only if we're running in debug mode. So if I run this normally with the run button, you'll notice that it does not pause. This error is expected. This is a very trivial fake example. This is not real code. It's just intentionally set up with some errors so that we can use it to practice debugging. But I'm not worried about this error. This error is totally expected. I was just trying to illustrate the fact that if I click run, it ignores my breakpoints. If I want it to pay attention to my breakpoints, you need to make sure that you're using the debug mode instead. So if I click debug, now, whenever it comes across a breakpoint, it will pause. We'll pause execution at That's what a breakpoint means. Breakpoint means break here. And there's a whole bunch of useful information that the debugger tries to provide to us to help us figure out what the errors are, what the bugs are in our code. So over here on the left-hand side, you'll see the variables window, which there's nothing really in it. Oh, there's args, but nothing really in it yet because this is the very first line of code. We haven't done anything yet. But as we create variables, we would see them show up. And as we move along, we will see variables show up on that top left corner. Down here, this is the call stack. So this is another very useful thing for debugging purposes. This keeps track of which methods are being called and the order in which they're being called. So I can see now the only method that is on here is the main method. It's the very first line of the program. So all we've done is the main method. But once we eventually call other methods, we'll see them appear in this call stack. This is useful because it's important for me to know where I've been, because that could have some information in regards to what problems I'm running into, what kinds of issues I'm seeing in my code. Once you've hit a breakpoint and are ready to move on, you have a few different options, all of which are specified up here at the top. The two that I want to start out with, though, and the two that are usually introduced first, are step over and step into. And the difference between step over and step into has to do with method calls. We can actually see with method call. Into. That's the debugger. I wish to go into that call and walk that method call line by line, step by step. If I click step over, it's telling me that I don't wish to step into this method. I wish to just execute that method and move on to the next line in the method that I'm currently in. So step over will generally stay in the method where I'm at. Step into will take me to whatever method is being called. And it's up to us as programmers to make that decision, right? Should I step into or should I step over? There's never going to be one right or wrong answer. The question to ask yourself is, do I the problem with my code is in this method? If I pick the problem that I'm trying to fix, the problem that I'm trying to debug is inside of that method, I should probably step into it. But if this method is solid, maybe it's not my method, right? Maybe it's a method that I'm getting from a library somewhere. I'm not going to debug somebody else's code. It's not my job. Or maybe I did reuse it, but I've already debugged it like crazy. I know the problem is not in that method, right? Then I might choose to just step over it instead. Again, neither option is necessarily right or wrong. It takes information about the program that you're debugging to help make that decision. But I do want to illustrate the difference between the two, right? So here I am paused on line 6. If I click step into, notice that I jump down to line 12, which is the first line of this make a thing method that was called on line 6. If I click the red square to stop and then start this over again, I want to show you that, okay, from line 6, if I click step over, notice that it does not jump into the method that's being called. It does not jump down to line 12. It just goes ahead and does all that stuff and then steps me over to line 8. So the step over button is going to keep you in the same method where you currently are. Step into is going to take you into whatever method is being called. It's up to us to decide which of those options is more appropriate, depending on what problem we're trying to solve. There's one other button here called step out, or you might also hear it referred to as step return. It's kind of the opposite of the step into button, in that if I am in a method, so if I use step into to come down here to this method, and then I decide that, well, actually, to where I was before, then you can click step out. And that will run the rest of the method that I'm currently in and take me back to where that method was called, which is line 6. So if you ever want to get out of a method and go back, which method am I going back to? It depends on the call stack, right? So if I uh, run this one more time and step into the first method, notice that that method call ends up on the call stack. So when I click step out, what am I stepping out to? Well, I'm currently in the make a thing method. Stepping out or step returning would take me back to the main method, which is exactly what happens when you click that step out button. All right. One other situation I want to show you, under the umbrella of kind of basic debugging basics. I'm not limited to just one breakpoint. I can have as many breakpoints as I choose, as I need to help me, solve this. So it's pretty common for me to have breakpoints in multiple spots. And so I'll add a few breakpoints. Right now I have 3 breakpoints. If I run the debugger now, I still pause on line 6. But this button right here, the button on the very left with the arrow, is called the continue button. And what the continue button does is it tells the program to continue until you hit the next breakpoint. So it's not going to go line by line like I would do if I was stepping. Instead, if I click continue, it'll just keep running until it hits the next breakpoint. So the next breakpoint that it hit was right here on line 12. And if I hit continue again, it'll tell me, okay, now here I'm at the next breakpoint on line 19, right? If you hit continue again and there's no more breakpoints left to hit, it'll just keep going until it hits the end of the program. So the continue button is a good way to help you get through the code faster so that you don't have to step through line by line to get to everything. If there's another breakpoint in the future that you're interested in, you can use the continue button to get you there without having to necessarily step through all of the 100 lines that are in between your current breakpoint and the next one. These are all the basics. I don't think I really covered much of anything so far that I hope that you've seen this stuff before, right? Maybe you haven't. Maybe you took the AP exam and didn't take the intro class here or whatever. That's totally fine. But these are, every programmer should know how to do at least the basics. And go above and beyond to show you some situations that we can use some more advanced kind of debugging techniques. And these are the kinds of things that I'm pretty positive you would not have seen in some classes before now. So I'm going to quit with this simple, this first example and move on to the next one. Example 2.java. Here we have so this is another very trivial example. This is not real code. This is just a made-up example to help us, learn various debugging techniques. But here we can see we create an array with 100,000 things in it, and then eventually later on, it's asking us to process the element at index 100,000. And even the students who are taking 131, 1301 this semester would tell me that this is bad because the last index is actually 1 less than that, right? If there's 10 things in my array, then the last index is 9. If there's 100,000 things in my array, then the last index is 99,999. There is no index 100,000, right? So, if you run this code just as is, it definitely will give me an error and tell me that it's out of bounds, which makes sense. Consider for a second, though, that I have this error message down here, but wouldn't it be nice to see what my variables look like when this error is fixed, or what the call statement looks like when that error is fixed, so that I could try and diagnose, try and figure out why this problem is happening. In order to do that, we're going to use a different kind of breakpoint. So the most common breakpoint is the one that I showed, break on a particular line of code. But in this example, we don't want to break on a particular line of code. We want to break whenever an exception is thrown, where an exception is an error that crashes my program, right? And in order to do that, I'm going to look at the breakpoints window down here, which is in the debugger. And you can see all my old breakpoints from the past example. I don't need those anymore. In fact, I could probably even just delete them because I'm done with that example. But what I care about are actually these 2 boxes. So I see 1 box for uncaught exceptions, and I see 1 box for caught exceptions. Uncaught exceptions are this. Whenever you have an error in your code and the code can't recover, doesn't know how to recover from that error, that is an uncaught exception. So if I check that box and then run this in debug mode, notice what happens. It has not printed out the error down here yet. It has not told me that I have out of bounds error or whatever the case may be. Instead, I am now paused. It broke. The debugger paused when this exception goes normal. So try and see that, hey, it's 100,000. That seems suspicious, right? That shouldn't be the case. It also lets me examine the call stack and trace the path through the code for how I got here so that I can see how that variable might have been affected along the way, right? So that is a much more useful way of seeing these kinds of things if I'm just trying to use the outputs. Some breakpoint exceptions. I'm sorry, not breakpoint exceptions. Exception breakpoints. I said it backwards. Exception breakpoints. Very valuable. This is one that I use all the time. If I'm getting errors when I run my code, turn on the exception breakpoints. That way, the next time an error gets thrown, I can examine the variables as they existed when that error happened and try to use that information to help me figure it out. Yeah. So that's one, kind of new, hopefully useful type of breakpoint for you to consider using the next time you're debugging some code. Let's take a look actually at the next example. I'm going to click the red square up here and move to example 3 now. And example 3, again, this is not real code. This is just an example to help illustrate debugging. But this is perhaps one of the more realistic examples that I'm going to show you today. Because if I run this a few times, notice what happens. It fails, and it tells me, all right, bad index at value 80. And if I run it again, it says, oh, okay, bad value at index 62. And if I run it again, it says, oh, okay, this time there was a bad value at index 51. And so, okay, clearly there's a problem that is causing this code to fail out, giving me bad values, but it's not consistent. It's failing at a different point every time. Actually, I want to show you 2 different ways that you could maybe consider approaching using the debugger to help you solve this problem. One, notice that the issue where it says, everything where it says there's problems is occurring line 16, but it's due to what's happening in this loop. So if I were to set a breakpoint in this loop on line 11, for example, and then try to debug this, well, recall that the point is moving. The point of failure is changing. There's a couple of reasons why that could happen, right? Maybe there's randomness in my code, so that could obviously make the failure point move around depending on the randomness of the numbers. If I'm using an outside data set, then the value of that data set could have an effect on how my code runs. But if I think the problem is here inside of this loop, so I set a breakpoint on line 11, and now I want to try and figure out where the issue is. Well, I'm in this weird situation now where, okay, if I click continue, I end up in the same breakpoint as before, but just on the next iteration of the loop. And how many times do I have to do this? Stepping is even worse, right? I can step through this loop as many times as I want to. You can see the value for I is continuously counting up. But how many times am I going to have to step through this loop before I find the problem? Because I don't care about the ones that are working properly, right? I only care about the ones that have the bad values. I only care about the ones that have the problem. So I could sit here and click all day. I'm up to I equals 30. Continue goes a little faster. So let me try that one. This morning in the first section, I think I had to click this button 80 times before I found the one that was bad. And it's similarly taking a long time today. All right, here we go. 70. Oh, all right, 75. 75 looks like the winner this time around. So I had to sit there in that loop, clicking the step button or the continue button. I hit that breakpoint 75 times before I finally got to the value that was causing the problem. Maybe you run into that situation before. I definitely have, right? It's annoying. Trying to set breakpoints inside of loops is very annoying for that reason. There's a lot of iterations that are working fine. I don't care about those. I don't need to pause on those. I just need to pause on the iterations that aren't working. Well, let me show you a couple of techniques to address this problem, one of which actually isn't going to help us here, but will be very useful in some situations. We can edit the breakpoints to have conditions associated. So very, very useful technique. If I right click on the breakpoint and I hit edit, by default, it wants me to enter an expression, which I do want to talk to you about, but I'm going to take a little detour first and switch this over to hit count. So this is quite literally saying the first 59 times you hit this breakpoint, don't stop. But once you hit it for the 60th time, then I want you to pause. So if you know for sure that the error is going to occur the 60th time through this loop, this is a great thing to do. That way you don't have to keep clicking that continue button over and over and over and over, hitting that breakpoint to get to the 60th time through the loop. And so, I can set that and run it through the debugger, and we'll see. Oh, so here you can see why it's not going to be effective for us in this case. The bad value moves around. So this time it crashed before 60 iterations. It crashed with only 39 iterations. If I try and debug it again, I might get lucky. And okay, this time the error, so I made it, right? I is 59. I've already taken 60 trips through this loop, and now it's paused because of that hit count. But unfortunately, this still doesn't solve my problem for this particular example because it's not happening on iteration 60 every time, right? It's bouncing around. So how do I make a breakpoint such that I can stop on the proper iteration even when that iteration could be different every time that I execute the program? That's what the other kind of breakpoint type is useful for. So let me stop this using a hit count. I love using the hit count. I think it's great example, just not the right solution for this particular problem. So I'm going to take the hit count off. I'm going to delete it. And then I'm going to edit this breakpoint again. This time I'm going to use an expression. So quite literally, you can enter any Boolean expression that I want. Any Boolean expression. When the Boolean expression is true, then I will pause at that breakpoint. If the Boolean expression is false, I will skip that breakpoint. I will not pause. So think about that. What is the case where I want to pause? I'm worried about situations. So the bad value, again, this is an arbitrary example, but if it finds a 0 in the array, that is a bad value, and that's what's causing it to error out. So an expression that I could use to help me with that is if the value in the array at position I is equal to 0, then I want to pause at this breakpoint. That is the iteration where things are going wrong. That is where I want to stop. So I'll go ahead and enter that in for my expression and set the debug, or run this through debug again. And you'll notice that, wow, it says 0. Is it really? No, did I type in the expression wrong? Shouldn't have stopped at 0. Why did it stop at 0? My array. Oh, I see the problem. It's a capitalization error. That needs to be a capital A. I'm surprised that it didn't get some sort of syntax or other issue. That's interesting that it reacted the way that it did to that typo. But yeah, okay. Let me fix that typo and try it again. All right, here we go. Now we can see from the variables window that I'm on the 73rd trip through this loop, the bad value, right? So now I can take a very closer look at all of my variables and the call stack and everything to see if I can figure out where the problem is. And the nice thing is that if I stop this and run it again in the debugger, this time it automatically paused at the 94th trip. So I don't have to guess which iteration it's happening on. My expression for the breakpoint is helping me find the proper iteration that I care about so that I don't have to keep stepping through this loop up to 100 times the time that I try to run and debug this program. That conditional expression helps me break at the proper moment so that I can then do further investigation, trying to figure out why things are not working at this point. But again, this is just an arbitrary example, so everything here is working as it should be. Just wanted to show you all those neat little tricks that you can use to stop your code at various times. And there's actually one more type of breakpoint that I want to show you that has to do with object-oriented programming. So the last file that I want to look at in here is this cat. This cat file. This is a cat object. I'm not really interested in the cat object itself. I'm more interested in the instance variable given here. So see that this has a couple of instance variables. Those of you who are familiar with object-oriented programming, which should be all of you because we cover it very first semester, know that the instance variables are a very important part of any object. And so if we're debugging things that use objects in particular, knowing when these instance variables change is very useful to us, right? It could have a very big effect on how the program is working. So it would be nice if there was a way that we could pause execution of our code when these instance variables are being manipulated and make sure that they're being manipulated in the proper way, in the proper conditions. This is actually called a watch point, or it might be called a data breakpoint, depending on which IDE you're using. It can be a little tricky to get it set up in VS Code. Whoops. Here we go. So I'm going to start by, down here there's a main method. I'm going to start by just having a breakpoint in my main method right here on line number 30. This is just a regular breakpoint, right? Not one of the special data breakpoints. But if I go ahead and run this in the debugger, in the variables window up here, I don't actually see any objects yet. This is calling the constructor. So I need to do a step first. And now I can see that, oh, okay, there's an object here. It's a cat object, surprise, surprise. And if I expand it out, I can see these are the two instance variables. So there's the isHungry instance variable, and here is the name instance variable. Let's say that I care about the isHungry instance variable, and I want to follow that instance variable as it gets changed and updated throughout my code. If I right click on this, I'm going to focus on these three options down here. The first one says break on value read. The next one says break on value change. And the third one says break on value access. So break on value read, just like it says, if I ever read that, I'm gonna pause. I'm gonna break. Break on value write, or break on value change, just as it says, anytime I modify that instance variable, I'm gonna break. And then the last one, break on value access, is both. Anytime that I look at that variable or anytime that I change that variable, break. So you have control. You have control over, how you want to pause execution as it relates to that data type. If you're only worried about modifying the instance variable, then you would pick break on value change. If you're worried about reading, you pick this one. If you're worried about both, you pick the bottom one. So I'll pick the bottom one. We'll see that down here, it now says cat isHungry has an access breakpoint set on it. So that means that anytime I read that instance variable or change that instance variable, my code is going to break. It's going to pause. And you can actually see that in action by clicking the continue button. All right, I'm now paused on line 13. There's no breakpoint here, right? The reason it paused is because you can see that I'm accessing that instance variable. I'm changing its value. So it's paused at that point. If I click continue again, all right, here's the next time. This time I'm not changing it. I'm just looking at it. I'm just reading it. But still, I said, anytime you access that instance variable, I want you to pause. So this will let you follow an instance variable the whole way through the program. Make sure that every time it's changing, it's being changed properly. Every time you're reading it, it's being done in a proper way. Again, if you're using object-oriented programming, this is a pretty essential way of learning how to debug your objects. And I use this all the time. This is actually probably one of my favorite debugging tricks. I try and teach students about this all the time. So I would encourage you to, get some practice with it as well. The next time you're working on an object-oriented style program. So that kind of ends the different types of breakpoints and debugging things that I was hoping to show. I have one other debugging related thing that I'm going to talk about next before I switch into files. But before I do that, does anybody have any questions about anything I've covered up until this point? Yes. Oh, I'm sorry that you're falling behind. Yes, I am recording this. I am recording right now. Sorry about that. Sorry if I was going too fast. My apologies. I would encourage you all to force yourself to try and do this, right? Try and do this stuff yourself. Using the debugger, there is a learning curve. And I think a lot of students avoid using the debugger because it feels like it's going to take extra time to learn how to use the debugger properly before I can actually use it to help fix my problems. And that's not necessarily wrong, but now is the time for you to be learning this stuff, getting used to using this tool. It's worth it. It's definitely worth the time and the investment, right? It won't always take you extra time to learn how to use the debugger. If you get enough practice doing it, then you'll be a lot more effective at debugging code using the debugger than maybe alternative methods like print statements and stuff. But you have to practice, just like there's a learning curve with Vim, right? It's the same kind of idea. Putting in the effort, putting in the hours is worth it. So I would encourage you to force yourself to try and use, especially some of these more advanced debugging techniques on your other homework assignments for your other classes, for example. But before we move on and talk about files, I want to show you one more little debugging exercise, and that's on the command line. So even though we're not super command line focused today, we're still going to be using the command line in this class. I actually want to start off by saying I don't like debugging on the command line. I'm not doing it because I want to. I'm doing it because I have to, right? So debugging on the command line is never my first choice. If I really need to debug something, I would much rather do it this way with the nice buttons and the nice windows for me to look at. But as I've tried to illustrate before, you may not have a choice. If I'm SSH'd into a computer, all I have is the command line. I don't have my IDE. I don't have my debugging tools. I have to do it via the command line. So sometimes that's the option that you have. So even though this isn't I would argue that debugging via the command line is not as essential of a skill. You certainly won't be using it as often, nowhere near as often as just using the traditional debugger through your IDE. I'm still going to take a few minutes just to kind of show you how to work through that process in case you ever do find yourself in that situation. Because I've definitely found myself in the situation where I didn't have my regular debugging tools. I had to do it on the command line because I was remoted into a server that was halfway across the country, right? It happens. It happens. So let's take a look at how we can debug stuff via the command line. So here I am on the command line first, and this is where I checked out my repository. There's my repository right there. So the first thing I need to do is cd into that repository. Inside of here, I see there's a source folder. That's where my code is. So I'm actually going to cd into the source folder as well. And then inside of the source folder, you see this debugger. So I want to actually make it clear that while yes, it is a directory, it's also serving another purpose for us, which is as a package. Be willing to bet many of you have not thought too much about what a package is or what its reason for existence is. Java quite literally is just a folder. Quite literally is just a directory. But it does matter when we're compiling our code and running our code. We have to be aware of the package. That's information that we have to pass when we compile the code. So when I showed you how to compile and run code on the command line just last week, we didn't have any packages, so it was very straightforward. Compile the Java file, run the Java file, run the program. But with a package, it becomes a little bit more involved. So with the Java C command, instead of saying example1.java, which is in fact the name of the file, I have to put the package out in front. So I have to say debug. Oh, that's not good. Let me clear my screen and type this over again. Debug example1.java. And when we run the code, so last week I would have just done Java example1, right? But that's not going to work. It's not going to be able to find it because I did not have this. So I have to make sure that when I run the program, I also include the package. The tricky thing to remember here is that while we're used to having folders and directories with slashes, when you're doing it as part of a Java program, it becomes not a slash, but a dot. So if I say this with the package out in front, this will actually run. And I know it threw a null pointer exception, but that's actually what I expected to happen. That program does have an error in it. It's intentional. So it did do what I thought it was going to do. Even though it looks like there's an error, I expected that error to happen. This isn't debugging though. This is just a plain old run. If we want to debug the code, then we have to back up a step. And when I use the Java C command, you have to pass in the -g. So when we compile the code, which I want to remind you, that's the act of taking the human readable Java code and turning it into ones and zeros, right? If I want to be able to debug that code, and this is true even if I'm debugging it in VS Code or Eclipse, I have to compile it with the -g flag. The big difference is if I'm debugging it in VS Code just puts the -g flag in it, right? I don't have VS Code takes care of all of that for me. But if I'm doing it manually myself and I want to debug, I have to remember to put that in there. So now the rest will be the same. Not txt, Java. Okay. So now it's been compiled with the ability to debug. Actually, though, before I get into that, let me show you that if I do this, nothing's... Oops, did I type it in wrong? Oh, I made the classic mistake. When you're running the Java command, you don't put the .java on the end. You're not referring to a file, you're referring to a program name. So that was my fault. If I do this, it still just looks exactly the same as before, which is because there's a separate command for debugging your program. So if you want to debug your program, don't use the Java command to run it. That'll just run it normally. You want to use the JDB command for Java debug. So the JDB command will take us into debug mode. And it's now waiting. It says initializing the Java debugger. It's waiting for me to tell it the required pieces of information to do the debugging, which the first step is to set a breakpoint. You have to have a breakpoint. Otherwise, we're never going to have a place to pause and examine variables and things like that. So in order to set a breakpoint using the command line debugger, we'll use the word stop. There's actually two ways that you can set a breakpoint. You can either set it by line number, which is probably the more common way, or you can actually do it by method name. So if I want to just stop every time I reach a particular method, there's a way to do that as well. If you're doing it by line number, you would say stop at. And then you would say debug dot example1 colon, and then the line number that you want to stop at after the colon. So for example 1, do I still have that? Here it is. Line 6. That's where I had my breakpoint at before. So I'll use line 6 here. So if you want to set a breakpoint on a specific, this is how you do that. So stop at, and then include the name of the program, colon, and then the line number you wish to stop at. It says it will be set after the class is loaded. So after we set the breakpoint, if we actually want to utilize the debugger, we need to type run. Whoops. Oh, run debug.example1. That's the more proper command. All right. After that's happened, you can see it's telling us that, okay, you said there was a break. Line number 6. And more to tell us breakpoint. All right, it even shows me line number 6. That is the full line of code that I'm currently at. And from here, we now then need to do the typical debugging things, such as taking a look at variables and things like that. We actually don't have any variables to look at. This is the first line of code in the program, but if I want to, I can use, for example, the list command, which will show me not just the current line that I'm on, but also show me the other lines that are nearby so that I can use that information to help me debug. If I want to go to the next line, remember that there were two primary ways that we control the debugger. One was to step into, and one was to step over. If you want to step into, that's going to be the step command. I know it's a little bit confusing, but if you just type the words on the command line debugger, that is equivalent to step into. Step into. And we can verify that because after we step, notice that I didn't jump down here to line 8. I actually jumped down to line 12, which is the first line of the method that is being called. We saw that earlier when we ran through this example in VS Code. If you want to do step over instead of step into, then you would just use the word next. So the word step is equivalent to step into. The word next is equivalent to step over. And if I run next, you'll see that, okay, I did step down to the next line. I think you can even do a number. So like next 3, maybe. Well, that didn't seem to work. All right, I thought you could step more than one line, but that doesn't actually appear to be working the way that I thought it would. So don't worry about that. But next, do the next line, set will get you to step into, and then once you're finished, you of course can type exit to get out of the debugger and back to the. This used to be the only way to run a debugger. We're talking 50 years ago, right? Before I was even born. Not that old. But yeah, this used to be the only way to debug. And even though it's not a way that's used so commonly anymore, I still like to see it, if for no other reason than a nice little reminder as to how far we've come and how much easier to use the debugger is now than all the people who had to debug stuff via the command line on the 70s, because in the 70s, because there was no other way to do it back then. That's just the only way for us to do it. So be thankful, at least, that we have these more advanced debuggers at our disposal. Debugging via the command line takes longer. It's not as easy. You can't see as much information. So, good skill to have. Hopefully you never have to do it, but at least you know that it is an option, that it's there should you find yourself in a situation where you do need to. That covers everything that I wanted to say about debugging. So I am going to shift over and talk about files with the remaining time that we have left. But before I do, does anybody have any questions about the debugging stuff that we covered today? Yes. What's the list? The list command actually just shows me the lines of code near to where I am. So if I go back into the JDB, and do I still have my breakpoint set? I don't actually remember. Oh, no, I didn't have any breakpoints set. So stop, debug at line 6. Oh, yeah, I forgot. It's stop at. All right, now I can run. Ah, I just totally, yeah. Does this mean that it will not keep a record? Well, you're kind of seeing why this is a bit more cumbersome. Uh, it's not going to keep a record of the breakpoint that we set after it exits. I have to reset those breakpoints over again. Yes, yeah. So you're kind of seeing me fumble around with this now. Like, it would be nice if it remembered the breakpoints that had already been set on the previous example. And there may even be a way to do that, but the default is not to remember that information. So now I finally remembered to set this properly. And now if I run this, uh, here I am at the breakpoint. The list command is just showing me quite literally the 4 or 5 lines, 4 or 5 lines. It's just giving me more context. Without the list command, this. So it's just letting me see a little bit more about what's around me. Helps me make a decision as to whether I need to step into or step over, depending on what lines I see in my current neighborhood. Yeah, good question. Any other questions about the debugging stuff before we shift over and talk about files? Last 20 minutes or so. All right. Great. So yeah, I am going to spend the last 20 minutes or so talking about files, and the reason I do this, a lot of groups like to use files in final projects, and I actually am a big fan of this. I like students using files on the projects. You don't have to. There is some, flexibility in terms of how you proceed down the project. We'll talk more about that in a couple of weeks when we get closer to the project. But this is such a common thing that I get asked about, that I like to make sure to go through the basics with everyone in class, so that if your group does choose to use files on the project in a few weeks, we get into that, you already have some of the basics that you can refer back to. So we're going to cover two main things as it relates to files. We need to talk about how do we get stuff out of files. So how do I read data from a file? And then we also need to talk about how do I get stuff into files? How do I write stuff from my code into a file? So let's go ahead and begin. We're going to start by reading, because I think that's actually probably the easier of the two. And I'm going to start by making a new place for me to work. I don't want to use any of these examples. So I'm going to right click and make a new file called filepractice.java. And I'll put a main method in here. Okay. So the first thing I want to show you is I have a file of information. How do I read data from that file into my Java code? Well, the first thing that we need to do is to make a file object that represents the file that we wish to access. So this is provided to us by Java. We'll give it a name like input file equals new file. And then inside of the parentheses here, we have to put a path to the file that we wish to. 99% of the time, this is going to be an absolute path. I'm sorry, I said that exactly wrong. It's going to be a relative path, not an absolute path. I very, 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 very rarely like to see absolute paths here. For the main reason being that all computers are different, right? As soon as I take this code and I move it from your computer to my computer, chances are that absolute path is not going to exist anymore. So we're going to use relative paths here the vast, vast majority of the time. If I do something like this, file.txt, that relative path is telling me that I should be able to find the file that I'm talking about in the folder, the main folder for my repository. So that would trying to show you exactly what I mean by that. So this is the folder that I cloned when I ran git clone, right? If I'm saying that I want to read a file and it's called file.txt, that means that it expects to find it inside of the main folder for that repository. Is that where it should go? I think that's an interesting question to ask, right? I think actually, ideally, there would be another folder for my data separate from my code. So, I might rather do something like uh, data slash file.txt, which in our case would mean that I need to make a data folder here. And then within this data folder, I would then make a new file called file.txt. And I'll even open this up and put in some text just so that we have something to read out of that file, right? You can see that when I did that, VS Code also detected that I made that folder called data with a file in it called file.txt and updated everything over here accordingly, which is nice. It's nice that it was able to detect those changes. Okay. You can see there is still an error here. That's just because I need to do an import. I need to import the file class in order to be able to use it. So the fastest way and easiest way is to just hover over one of these red errors and select, hello? Okay, if it'll let me, select quick fix, which it's not letting me do. It's being a little annoying right now. I want to click right there where it says quick fix, and as soon as I move my mouse, it disappears. Stop doing that. How do I get it to actually let me do that? Oh, here's a little light bulb. That's another way. Yeah. There's a little light bulb on the left. Let me click on that one. Import file. Maybe it would have been faster for me to just type that out directly with all the weirdness that was happening on with those buttons, but regardless, we have to import that. Why are you still unhappy with me? I imported you. Oh, yeah, there we go. Yeah, just took a second. I was wondering why it was still mad at me. Okay. For reading files, the good news is I'm going to do something you're already familiar with and you already have some experience with and already kind of know how to use. We're going to use our good friend Scanner. Scanner is something that we introduce in the intro class, right? Very early on. We introduce it as a way to read input from the keyboard, so to actually have a person type something in. That's not what we're using it for here, though, right? So if this were 1301, I'd probably have a line of code that looks like something like this with system.in inside of those parentheses. System.in is the keyboard. So if the input that I'm trying to get is from the keyboard, this line of code is good, but that's not what we're talking about. We're talking about files. So instead of system.in, I'm going to put in the input file that I created on the previous line. I need to import this scanner just like I did before, so make sure to have an import line for scanner up here. But even after I fix that import, you'll notice that there's still an error. There is still a problem. It's still unhappy. And if I hover over this error, it's going to tell me unhandled exception type. And this is an illustration of the fact that there's actually two different categories of exceptions in Java. Exceptions, just a reminder, are anything that can crash your program. So the classic example of that is an array index out of bounds exception. That's probably the very first exception that many people run into, right? I have an array with 10 things in it. If I try to access the element at position 20, there is no position 20. I'm going to get an array index out of bounds exception, and my code is going to crash. It's going to stop. It's not going to run properly. This is a file not found exception, which would happen if, for whatever reason, the input file that I'm trying to use is not there. Think about the differences between those two, right? An array index out of bounds exception, I can fix by figuring out where in the code I made a mistake. But if the file is not there, right? If I'm trying to open a file and the file is not there, there's not much that I can do from the code to fix that. Whoever is using the computer may have decided to delete the file, and I can't stop it. Or maybe they decided to rename the file. I can't stop doing that. So this is a different kind of exception type. These are called checked exceptions. Whereas array index out of bounds is an example of an unchecked exception. There are lots of other types of unchecked exceptions that you probably run into, just one of the more common ones. A checked exception means that I can't ignore this possibility. I have to be prepared for the case when this file cannot be found. I have to have some sort of code or some sort of plan in place for what to do if this file is not found. So in order to do that, we have two options, which it will happily present to us. If I can get it to show me the two different options. Yeah, here we go. So the two options that I'm going to talk about are this top one, adds throws declaration. That's actually the first one I want to talk about. Even though I did this one, I would say that this is the bad option. This is not a good choice. What this does is it says, acknowledge that this line of code could potentially have a problem if the file is not found. But I'm going to make that this problem. So adding that throws declaration here basically says, whoever uses this program, they're the ones that has to worry about that, not me. So it's not a very nice thing to do. If you're coding professionally and you use this option, that's a good way to get one of your colleagues, one of your coworkers to come find you, knock on your door and be like, hey, why didn't you handle this exception? Why are you throwing it and making me worry about it when you could have handled it yourself? So let's talk about the other way. Let's talk about the other option. I don't like that option. I like the other option for dealing with checked exceptions, which is to surround with a try-catch. So this is probably what I'm going to pick 99% of the time. Why are you still underlined in red, though? Oh, okay, there we go. I don't know why it's having that delayed reaction. But regardless, this is this code that could cause the problem. It's inside of the try block. If the exception doesn't appear, everything works as it's supposed to, that's within the try, and it just skips the rest of this. We don't even have to worry about it. But if that exception does appear, if the file not found exception does happen, then this catch block will catch that exception and run whatever is in here. And so at this point in time, we need to do something to try and address that. If we can fix it, that's the most ideal thing to do. So maybe we can use a default file instead. Maybe that's not an option, though. At the very least, we should probably do some sort of message that says file not found, so that whoever is running this knows that, hey, I tried to do this. I couldn't have more information to provide here. Obviously, that's better. The more information you can provide, the better. So whoever's running into this issue can read that information and use it to help solve the particular issue. But this is the way that we deal with exceptions, or exceptions in particular. We have it's required. Java requires us to consider the case when the file is not there. So with all of that out of the way, we can now finally get to the actual act of reading stuff in from a file. The nice thing is that I'm hoping you kind of remember how to use the scanner already. So, I'm going to make a string variable, and I'll say in.read. Oh, I'm sorry. In.next line is probably good to read the next line out of the file. And if I want to, just to make sure everything's working, I could print it out afterwards. Okay. So if I run this code, it says hello. That's great. That's the line that was in the file, right? And just to verify that it works, I'll change it to be something else. And I'll go back and I'll run this again, and hopefully I see that, okay, yeah, it found the new thing. So it's only reading one line of the file. If I wanted to read multiple lines of the file, you need a loop. So line at a time, process that line. Or you may not even want to go line by line. You might want to go item by item. Maybe I want to read an int, and then I want to read a string, and then I want to read numbers. It's up to you, right? And with the scanner, you're provided that flexibility to read in the file in whatever chunks you need to. Let's talk about the opposite case now, where we need to write stuff to a file. So just like we did before, the first step is to have the file that we wish to write to. And so I'm actually ahead of myself here. File out. File is equal to new file, data out. This file doesn't exist yet. The good news is that I expect it to create that file for me if it doesn't exist. So that I'm not too worried about. But, well, actually, is that true? I guess we'll find out in a little bit. Because the next step is to do a print writer. So we used the scanner class to read stuff in from a file. We're going to use print writer to write stuff out to a file. This is not the only thing that's available to write out to files, but I think it is one of the more convenient ones. The way we do this is by calling the print writer constructor and passing in the file that we created on the previous line. Now, it already imported the print writer, but you'll notice we actually have the same issue that we had before, where it's saying, so I think I actually was, I misspoke a little bit earlier, because it wants us to be prepared for the same situation. What if this file doesn't exist? What should I do? And we're going to solve it the same way. We're going to solve it using a try-catch statement. So just like I did before, I'll surround this with try-catch. Down here, I would put some sort of, descriptive error message. Could not find output file. And then here, inside of the try statement, this is where I'm actually going to add a line of code to content. The nice thing is the print writer is set up to print things in the way that you're already used to printing things. So I would say something like printer.println. You already know how to use the println method. It's not the exact same println method as from system.out.println, but it works in very much the same way. You're just printing to a file instead of printing it out to the console. So this file doesn't exist, and I'm actually kind of curious as to what is going to happen if I try to run this and this file doesn't exist. I suspect that it's going to get down to this exception, but let's try it and see. Actually, it didn't. It didn't hit the exception. Did it make the file? Oh, it did make the file. It ran without errors, but there's nothing in it. There's nothing in it. That seems a little bit curious, right? I made a mistake. And I made a very common mistake. And it's not the last time I'm going to make this mistake. I make this mistake all the time. All the time. With reading, it's not that big of a problem for us. But with writing, we have to be very, very conscious, have to be very, very careful of closing the file once we are done with it. This is the equivalent of saving the file. So because I printed this out and I never closed the file, I never actually got saved the file itself. That's why I didn't see that content when I opened up the file. But after I add that close statement in and I run it again, hopefully this time, when I open this up, there we go. There's the message. There's the message. So that closing of the file thing, you're supposed to do it even when you read files, even when you're using scanner to read files in, you're supposed to close the scanner. In fact, some of you have maybe seen that error message before, right? Scanner resources never close or something like that. You're supposed to do it. The reason why it's an easy mistake to get into is because if you're reading, it actually doesn't usually affect anything. It doesn't break anything, right? When you're writing, though, it definitely does. Definitely breaks stuff. Have to remember to close your files when you're not writing to them. This can be a little bit tricky because what if I want to open that file up again later and write some more stuff to it? Then I have to go through that whole process. File, creating the print writer, and doing the try-catch and the whole deal, which is why I will leave you with this last thought, especially when we get to the project. Especially when we get to the project. Anytime we're doing stuff with files, anytime I'm opening a file to be read, or anytime I'm opening a file to be written to, this should be in its own separate method, separated away from all other parts of the code. We do not want that is interacting with to be mixed in with all of the other code that is not doing stuff with files. A big reason for that has to do with the topic we're going to talk about on Thursday, which is testing. Testing is already difficult, but the bigger a chunk of code is and the more stuff it tries to do, harder it is to test. So all this file stuff in the same method as a bunch of math and data processing, it's going to be impossible for me to test that effectively. It's all lumped together into one big method. So one method for manipulating the files, one method for doing the math or doing the data process, whatever the case it is. That way I can test that directly and not have to worry about files getting in the way of me testing that other, functional part of my code. But that's the topic for Thursday. I think I've covered all the ground I was hoping to today. I'll stick around for a few more minutes if anybody has any questions, but have a good rest of your day, everyone. I'll see you back here on Thursday when we're going to talk about unit testing.